All right, hello. We're moving on to example 5. So example 5 says a projectile is launched from y0 at the initial velocity, an angle alpha. All right. So we are to find the work done by the weight in going from A to B. Okay. Is it the only force? And then we have to find the velocity of V acting on the particle. So we could see that there's a horizontal line over here with A to B. That gives us a base of how we're going to represent the problem. So the work done by A to B will be rewritten as a equation, right? We're going to do again the change of x, the change of y, vector, the first vector and the final vector. We're also going to do mg and the change of y. We're all going to put it in one big equation. Now we are also going to use work equals the change of kinetic energy, which in this case will be 0 since there's no change. It will be the same, but we're going to have to rewrite it. So in this case, this is number 5, I believe. Number 5. So number 5. So A. So we're gonna do, as I said before, the work from A to B, which will equal the force acting upon the change, right? The change. So we're going to represent this as mg, the negative of mg, times the change of x of the vector, initial vector, plus the y, the change of y, the second vector. So we are going to represent it like this. Change of y equals 0. 0 because the parabola from A to B, no difference. So is it the only force? So it says find the work done by the weight in going from A to B. Is the only force. No, the only force, it's not the only force. The only force is U and gravity. Yeah. And it says find the velocity V acting on the particle. So, in other words, work from A to B, the change in kinetic energy, kinetic final minus kinetic initial, we get that formula, and it's my bad. My bad. So as I was saying, 0 equals the change. My bad. The change of kinetic energy. Kinetic energy, kinetic final equals kinetic initial in this case. Alright, because we're gonna do velocity of V equals velocity, the starting velocity. Right. Kinetic F, kinetic I. So we're going to do half of mv squared of the final minus half of mv of the initial. So we are going to write it. So it's a part of the explaining. So it's 1/2 mv of final equals 1/2 of the starting, of course, which will equal velocity of v and the initial. As simple as that. But now we're going to part B. Find the work going from A to C and V. See? So this one is a little more complicated. Why? So we're gonna use the same equation. So as using the same equation, it's a work equals F times the change of S, right? We're going to use that for the remainder of the exercise. And we're going to use mg of y1 minus y2, right? But we gotta use what is from A to B. I mean, from A to C. So A to C, right. So formula again, but we're gonna use C. So this is the starting, and then the C, and 0 is from A to B, or the change in kinetic energy, however you want to do it. So we're gonna simplify as best as we can. So it will be 2m times 1/2 m2 m of the initial velocity initial, and the y initial. In other words, it will be simplified as this, right? Yes, and that will be, so with a given value, for example, we could do VC2 10 squared plus 2g times 100, which will equal 100 times 20. G is the gravity, so it's 9.8, but we're gonna round it to 10 to make things easier, and it will give us an example of 2,100 meters per second.